In this video, I'm going to extract a single channel profile using LSDTopoTools. The first step would be to install LSDTopoTools. If you go to our documentation website, you can scroll down to the installation bit. I'm not going to do that right now. I'm going to assume you've already got it. We use Docker containers as the kind of easiest way to install it. That's pretty easy on Mac and Linux, a little bit more difficult on Windows, but it does work on Windows. I've got one going right here. So I just fire up an LSDTopoTools container. This is the command. It's basically telling the container that the data on my computer is here, and then inside the container it also has a file system, so I'm just mapping the two file systems. So you would write basically just this if you've got Docker installed. If it's the first time you do that, it would have to grab the container from the internet, so that might take a little while. Once you get that, you can read the installation instructions and find out how you get all the software on this container. There's a setup script, but if you're doing this for sort of the second time, you can go into this LSDTopoTools 2 directory and just run the setup. You only really need to run the setup script if the code has changed. So what this does is it pulls the latest version of the programs or the code from the internet and compiles them. I've basically already done that, so this will go quite quickly. And then just look the programs are. Another little script. Okay, so now this is all working. I can check if the programs are in the path. They are. Okay, so now I'm going to look at some data. So I put my data into a data folder. I'm going to get a bit of data near Santa Barbara, so I made a directory called SB. How did I get the data? Well, I went to Open Topography, went on data, and then just downloaded some SRTM data. So there's a data catalog. You can go to the global data sets. You can, I want global data sets. You can go to the Shuttle Radar Topography Mission, get version 3, and then you just select a little area. So I selected a little area around here and downloaded it. That results in just a tarball. So you can see the tarball here. What do we do with the tarball? Well, I've got tar installed on the Docker container. So you can just do tar xzf rasters. Now I've got a TIFF file. LSDTopoTools doesn't like TIFFs. It likes NVBIL formats for historical reasons I won't get into now. But basically, you use something called GDAL to convert this to a NV file. And we also want it in UTM coordinates. So we need to call GDAL to do that. I can't actually remember the command, but in the documentation for TopoTools, you can go into the geospatial data thing, and then you just look up this section. So there's a GDAL warp thing here, so I'm just going to use this one, and I'll make a couple of changes. So I copy that in. Whoops. Copy that in. Okay. So I need to know the. Oops. I need to know the name. Oops. Sorry. So I need to know the name of the DEM that is coming in. Output SRTM. And I need to know the UTM zone. You can look that up on the internet. I just happen to know this is zone 11. Okay, if you Google UTM zones, you'll find that straight away. We also want to tell it that we use an NV format, so that -OF is output format. And I'm just going to call this sb.bill. Okay, so now I've now got a bill file in the right place. So the next thing I need to do is I need to run a basic metrics run. You can look up all about that in our documentation. So there's a whole section on, let's go up here, basic topographic analysis. The way our analyses work, it's always the same. You use a file to tell the programs what to do. We call those driver files. I'm just going to copy one from here. So I'm going to copy this thing. And I'm going to go into here. So you can see all the files both on Windows and in Linux because I've linked the Docker container here. So I can just make a new file, sb.driver. This will be an empty file. Yes. Okay, and then you need to edit this. I use a text editor called brackets. So here's this file in brackets. Just going to copy this out. So I need to tell it what the read name of the file is, SB. You don't need the extension. Right name, we'll just call it SB. This is a default for channel heads, but I'm just going to leave it like this. I want to, let's print a hillshade, true. Another thing I want to do now, I want to extract a single channel. So if I go into the documentation here, I can look at the basic channel extraction. So one of the options is to extract a single channel. True. Then the next thing is I also need to tell it where the channel head is, or the channel source. So it wants a file name for this. So I'm just going to call this, let's call it sbsource.csv. So this needs to be a CSV file that includes a latitude and a longitude, and it needs to have those two column headers, and the latitude and the longitude are the source of your channel you're going to extract. So where are we going to find that? Well, let's go onto Google Maps. Let's look at the terrain. Okay, so why don't we pick in here somewhere? So I'm just going to make a source here. What's here? Here is this place. So now I need to make a new file. So I called this sbsource.csv. So let's make a new file. It needs latitude, longitude, yeah, and I'm going to paste that in. And let's just make sure latitude 34, yeah, that's all looks good. Okay, now I'm going to save this. And I call that, so find where I was before. It was sbsource.csv. Save. Let's just make sure that's what I had. sbsource.csv. sbsource.csv. Okay. So that's all done. The name of this is SB driver. So I just want LSDTT. LSDTT basic metrics. And then I called that sb.driver. Okay, so it's done something. Okay, if you want to look at the output, well, why don't we use QGIS for that? So we started with, here's the data I had. Okay, so I started with an output. So this is what I got from Open Topography. This is a converted NV file. It's the same thing. Okay, and then I've got this source data. So it's actually, let's look at the CSV file first. I now have this file, single channel nodes. You could open that with Excel. So let's just try that. So this is the file. It's got an ID, which is, well, you don't need to worry about that. The row and the column are the rows and the columns within the DEM raster. The latitude and longitude, that should be self-explanatory. It's also got X and Y in the local coordinates, so that's going to be in UTM zone 11, easting and northing. It also has flow distance, drainage area, and elevation. The flow distance is from the outlet, yeah, so it goes down. This is the top of the channel, and it goes down from the top of the channel. We could just plot that. Oops. Insert. Yeah, here we have a channel profile. You can also look at that in QGIS. So here we go. We can do layer, add delimited text layer, find the file. Data, SB, single channel node. Yeah, and it already knows latitude and longitude. And because it's latitude and longitude, the coordinate system's always this global WGS 84 one. The EPSG is 4326. So we just add this. Ta-da! There's where the channel is.